Oh, hi there. I'd like to talk with you today about finding critical points. This is in the realm of optimization. We're finding extreme values for a function. I'd like you to recall what a critical point is. A critical point is a place where one of two things happens. Either f prime of c equals 0 or f prime of c does not exist. And that could either be we have 0 over 0 or infinity or minus infinity or whatever reason. I don't know what this value is / it's one of those two things. So I'd like to go through a couple of examples where we find critical points of functions. One of the, I'm going to use, I'm shamelessly using my book because I want to write down the functions correctly. Okay, let's first work on the problem where we want to find the critical points of f of x equals, I'm going to write down this polynomial, x cubed minus 27 x minus 20. We want to find the critical points of this cubic polynomial. So we're going to find the critical points. Critical points are these two places right here. So I think as far as finding critical points, broadly speaking, we've got a two-step process. Step one, f prime of x. And then step two is going to be to solve. Okay. So f prime of x, I'm going to use the power rule on this polynomial function. And I have that f prime of x equals 3x squared minus 27. Cool. And then step two, solve for equals 0 or does not exist. And I think it's important that I write down or does not exist, even for this simple polynomial, to remind you that that happens, because it's easy to forget those critical points. It's common for people to forget those. So is there anywhere that this polynomial can't be evaluated, or I would get infinity, negative infinity, 0 over 0, or something like that? The answer is no. F prime of x always exists. Which means that there are none of those. So step two then is to say 0 equals 3x squared minus 27, and then I'm going to solve for x. If you want to be super, pedantic about it, I would do it with a c right here, but I'm content with an x at this point. So you know what? I am going to do c's. I'm going to do c's because it's at a special point, c, critical points, where this is true. F of x is this function right here, and for c's, it takes on special values. So I am going to use c's. Deal with this big smudgy c. Okay. So the first thing I'm going to do is divide by 3 on both sides, and so I'll have 0 equals x squared minus 9. That factors into 0 equals x plus 3 times x minus 3. Whoops. C. I'm just so used to writing x's. Okay, which means that I have two critical values. I conclude that I have c equals positive and negative 3. Okay, so those are my critical values. And then I'll go off and classify them using the first or second derivative tests, but that's not what I wanted to talk about. I wanted to talk about finding critical points. Okay, so I think it's, broadly speaking, a two-step process. First step, differentiate. Second step, set it equal to 0 and solve, and consider the places where f prime doesn't exist. Now, since this was a polynomial, the derivative is always defined, and so we weren't going to find anything there. So let's change our example just a little bit and do a problem where f prime of x doesn't exist at a certain point. How would I find that? How do I identify that that's my situation in the first place? Like, how do you know that that's something you should be paying attention to? Well, let's do that for a particular example, which I'm going to write on the board in just a second here. Okay. I hope you enjoyed watching that erasure. I think it's kind of fun because, like, the marker ink like bleeds. Oh, it's fun to watch. I love using this tool. This tech tool is so cool. Okay, so let's find the critical points of g of x, and let's take g of x equal to 1 minus x to the 2/3. Okay. So one thing that we should pay attention to is that it's got some domain problems. No, it doesn't, because I'm taking cube roots. I'm squaring and taking cube roots. No, this function is defined everywhere. Yeah, because I can square anything, no problem, and I can take cube roots of anything, no problem. Odd powers for roots are just fine. Okay, so we're going to find the critical points. Remember this two-step process. One, I need g prime of x. So step one is differentiate. No problem, we can differentiate. Let's differentiate this. We've been working on the chain rule. We used our time wisely, and we got really good at the chain rule. So I've got this function that's a composition. At the outside, it's something to the 2/3. So g prime of x is 2/3, 1 minus x to the 2/3 minus 1. And now I need to chain out the derivative of the inside, and the derivative of the inside is -1. Let's simplify a bit and write that this is minus 2/3 times, let's see here. So this is minus 1/3, 1 minus x to the minus 1/3. And I don't like minuses. I mean, I do love minuses, don't get me wrong. But as far as doing this process, I feel like if I don't deal with this minus, so I think we should do the flip, because that's the thing that's really going to remind us that, oh, that's how I find places where the derivative doesn't exist. That was just a horrible mark. Boop, there we go, okay. So let's do that flip and find that that's equal to minus 2/3, whatever, I'm committing. Okay, minus 2/3 times 1 over 1 minus x to the 3rd. 1/3. Okay. Okay. So we want to find the critical points of this function. The critical points are two places. Either the derivative is 0 or the derivative doesn't exist. Let's do the doesn't exist. Let's do the doesn't exist first. So as far as where this doesn't exist, where does that not exist? That doesn't exist where the denominator is 0. Okay? So where does it exist? Where the denominator equals 0. So we need to take the denominator and set it equal to 0. Okay? So where does the denominator equal 0? Well, the denominator equals 0 is the same thing as saying that 0 equals 1 minus x to the 1/3. And if I cube both sides, then I have 0 equals 1 minus x, which implies that x equals 1. Okay, so we found a critical point at x equals 1, and it came from denominator equals 0. As part of So that's part A. So part 2B, the second part is where is g prime of x equal to 0? And so I'm literally just going to set it equal to 0 and then solve. So I'm going to say 0 equals minus 2/3 times 1 over 1 minus x to the 1/3. Now let's do some algebra. I'm going to do it in line here. So let's take and multiply both sides by -1. Okay, cool. Let's multiply both sides by 3/2. Okay, cool. So there's multiplicative constants. We can just kind of like make them go away super easy, which is nice. And we'll see here. Now so we'll assume that x is not 1, and we'll multiply both sides by this expression right here. Okay? So we're going to multiply both sides by 1 minus x to the 1/3. 1 minus x 1/3. But 0 times anything is 0, which means that my conclusion then is 0 equals 1. Which is like, okay, fine. This looks like garbage, but like this is kind of an okay place to be. What this means is that there are no g prime of x equals 0 points. Okay? So, so then this right here is the only critical point for this function. And if I hadn't considered where g prime doesn't exist, then I wouldn't have found it. Okay. So that's kind of a general process for finding critical points. Take the derivative, where is the denominator equal to 0, and then set the derivative itself to 0, and then solve. And that will lead you to the critical points. Good luck in your quest for finding them and then classifying them using the first and second derivative tests. Have a lovely day. Bye.